Okay, now we're rolling. All right, so proving statements about segments and angles today. So yesterday, or the day before, I guess technically, you guys did some algebra proofs where one column was doing the steps of the algebra and the other column was explaining why you were doing it. Today it's going to be proving some statements about segments and angles where we do essentially the same thing, where the column on the left is going to be you explaining your steps of why your logic works, or not why your logic works, but what your logic is, and then on the right-hand column is going to be explaining why that logic makes sense, or why you are allowed to say whatever it is that you say. So these are all going to have kind of the same basic setup. There's going to be some little picture, and then there's going to be some given information. Okay, and our first task is going to be simply to mark up the picture so that it represents the information that's given. Okay, so here's our first one. So let's say we've got segment AD. We've got this other segment coming through it like that. And this is going to be segment BE. And the intersection is going to happen at C. Alright, so our given information for this is the segment BE bisects segment AD. And also, CE is congruent to CD. Now in the picture, oh yeah, the picture doesn't exactly look like that, partly because the projector stretches things vertically. So CE looks a lot longer than CD, but we have to assume those two are congruent. And what we're going to try and prove with this given information and given the way that the diagram is drawn, remember there are certain things we can assume based on the way the diagram is drawn. So given all of that information together, we're going to use some deductive reasoning to prove that the segment AC is congruent to CE. Okay, and I said the first thing we want to do is we want to look at the given information and mark the picture accordingly. Okay? So BE bisects AD and CE is congruent to CD. So the bisects thing, we can't really mark that up just yet the way that that's written, but CE being congruent to CD, we can certainly mark that in the picture. So we're given that this segment and that segment right there are the same length. Okay? And we want to prove that AC is congruent to CE. Now sometimes, depending on the proof, sometimes you can look at the given information in the picture and you can kind of reason your way through it. And then the task becomes, can you take that path that you kind of saw in your head of the way that the logic kind of works, and can you write that down in a way that makes sense? Any details? Okay, so can anyone kind of see the path we're going to take on this one based on the information that I gave you? Yeah? So, like start with the BE bisects AD. What does that tell us? That C is the midpoint. Good. Okay. So we know C is the midpoint. If we know C is the midpoint, what do we know? Yeah. Right, that AC and CD are congruent. And if we know that AC and CD are both congruent, and we also know that CE and CD are congruent, do you see how that leads us to AC and CE have to be congruent then too? Yes. Okay. So that's what I'm talking about, trying to kind of see the logic, see the steps ahead of time so that you can kind of start to organize your thoughts a little bit before you begin. All right? Now, if you can't do that, that's okay. All right? We can just kind of get started and then see if we can kind of slowly work our way through what leads to what as we go. You're not always going to be able to do that. But let's see if we can start this proof off here, though. All right, so I'm going to basically just do what you guys told me there. Okay, we're going to start with the given information. And I know sometimes it seems annoying to have to rewrite stuff that's already written up there. But technically this does need to be part of your proof because you can't do anything unless you know this information, so it has to be included as part of the actual proof. The two columns that I'm writing down here, that's the only part of this that's the actual proof. But on the bright side, if you copy down the given information as step number 1, if you're on a quiz or a test or whatever, and I ask you to write a proof, you've already got partial credit. Okay? No one. I don't care how frustrated you are with geometry or how confusing it is or whatever. No one in here should miss this step. Not a single person should ever leave a proof completely blank. Okay? Anybody can do this. Okay? I could teach my 5-year-old daughter at home to do this. Take what you see there, copy it down. Done. Okay? Get those points in the bank. Okay? Then let's worry about the rest of it. Yeah? Well, whatever is written here as given is given, whether or not it's marked in the picture. Okay? I was just marking the picture with things that I saw over here to help me. Okay? So, knowing that BE bisects AD will lead us to some things we could mark in that picture later, but yeah. So, okay, so step number 2. What was the next thing that you guys told me? I asked you, let's start with bisection. What does that tell us? Yeah. Okay. So that's exactly what I'm going to write. C is the midpoint of AD. Okay, and then Y. How do we know? Okay, so you're using there what it means to be a bisector, right? So if we're using what it means to be a bisector, I've just used the definition of a bisector, right? The definition of a bisector is something that crosses a segment at its midpoint, right? So my justification would be definition of a bisector. Okay, so then the logic's going to keep going like this. Okay, because C is the midpoint of AD, then what do I know? What does that tell me? What was the next thing that we said? Somebody other than Savannah this time. What is it? C being the midpoint, and you've already answered them too. What does C being a midpoint mean? Yeah, Abby? Good. Yep. So AC is congruent to CD. So what's my reasoning for that then? Why? Yeah. No. Yeah?
Because C is the midpoint.
Okay, so what am I going to actually write as my justification? Yep. Definition of a midpoint. That's exactly what I just did. Because it's a midpoint, I know these two things are congruent. That's the definition of a midpoint. Okay. So, we're kind of up to the end here a little bit. I've been able to get to the point where I can say AC is congruent to CD. So if I mark my picture that way, AC is congruent to CD, what I'm really seeing now is that there are 3 segments in that picture that are all congruent to one another, right? Okay, so let's think about what we're going to use to finish this thing up, because we're right there. we want to prove that AC is congruent to CE, and we've got that in our picture now. It's one of those are two of the three that we know are all congruent now. But really, all that we've stated in here, as far as things that are congruent, I haven't explicitly stated that yet. I've only stated that CE and CD match, and that AC and CD match. So can anyone think of a way that I can take these two pieces of information, CE congruent to CD and AC congruent to CD, to show that CE and AC go together? Yeah. You got it. And what is that called? Yeah.
Transitive property?
Yes, sir. We're going to use the transitive property to finish it up. Okay? We've got two things, two segments that are both congruent to CD, so they're congruent to each other. That's using the transitive property when you do that. Okay? So our last step in our proof then, we can say that AC is congruent to CE. And our justification for that, transitive prop. Now, technically, it's the transitive property of congruent segments. But if you just write transitive prop, that's fine. I'll know what you mean and know that you were doing the right logic for that. Okay? So then, if this step here matches what we were trying to prove there, we're done. Okay? So we've got a 4-step proof for this one that got us there. Okay? Now, something that I do, I was taught this in college. It's kind of an old school way of doing it, but I was told that when you are done with a proof, you always write Q, E, D to show that it's done. It's like a little stamp that you put on the end of it. And those 3 letters, it's Greek, because proving things in geometry started with the Greeks, and that stands for quod erat demonstratium, which means, which is what we were trying to prove. It's the Greek for that. Okay? So QED, all you need to remember is QED means done. Now, I'm not going to mark things off if you don't put the QED on there, but I'm going to do it just because that's what I'm used to doing. Yeah. So, anyway, kind of a fun fact. Has anyone ever seen the first Pirates of the Caribbean movie? Yeah? Yeah, okay, so a long time ago. But, so in that movie, Johnny Depp goes on a tirade for a long time where he's like really mad at somebody. I can't remember what it was all about, but he was just like going off for a really long time about something, explaining why he was right and this other guy was wrong. And then at the very end of his rant, he screams QED. Like he's doing a proof, and then he's done. He says QED. It's just kind of funny. So, anyway, next time you watch the movie, look for that. I thought it was pretty funny. But, all right, everyone. Is it really that painful? Come on. Angles this time. This will be A, B, C. This is angle 1, angle 2. And then over here, angle 3. So our given information we're going to use with this picture is that angle ABC is a right angle. Well, you didn't know it till I told you it. It could have been 91 degrees or something. Also, you are given that angle 2 is congruent to angle 3. And we're going to use that information and what we see in the picture to try and prove that the measure of angle 1 plus the measure of angle 3 equals 90 degrees. All right, so see if you can follow the logic in your head before you begin on this one. Okay? Think about what I'm telling you at the beginning. This angle over here is a right angle. 2 is congruent to 3. If this is a right angle, angle 1 and angle 2, their measurements add up to what? 90. If these two add up to 90, and 2 and 3 are congruent, meaning they have the same measurement, doesn't it seem to reason that 1 and 3 should add up to 90 then too?
Yes.
Okay, that's the logic we're going to use on this one. Yeah, you may. Just be quick. All right, so we'll write in every proof. Yes, sir?
The given statement.
The given statements. Right, okay, so we're going to start with that again. All right, so number 1, angle ABC is a right angle, and angle 2 is congruent to angle 3. That is all given. Okay, so can we start from there then? Okay. So think about the given information. What would be a logical next statement that we could make about what we got going on here? Yeah.
Angle 1 and angle 2 equal 90 degrees.
That's right, but not for step 2. We have to go through one hoop first. Yeah.
That is angle 2 is congruent to 3, then angle 1 is congruent to 3.
Nope. Actually, we don't know that. We know we're trying to prove that 1 plus 3 is 90, but not that necessarily 1 is the same as 3. Because if these two add up to 90, like 2 could be 50 degrees and 1 would be 40. Then if 3 is the same as 2, it's 50. It's not the same as 1. Does that make sense? So we're not going to that. But I like the 1 plus 2 equals 90 idea, but we got to jump through one hoop before we can do that. Yeah.
Angle 1 and angle 2 are congruent?
Nope. We don't know that either. That is true, but actually we don't need to go that route just yet. Think simpler than any of the stuff you guys have been mentioning so far. It's actually something simpler than that. There's a statement that was made as one of the given statements that we haven't really dealt with before we can get to what you guys are saying yet. Yeah? We can put the square thingy in the picture. It's related. It's definitely related. Yes, Zach?
Is it that ABC equals 90 degrees?
Yes.
I just said that.
Well, you didn't say it loud enough. So, anyway, yeah. Notice that nothing, and this might seem like a silly thing that we have to do, but technically, we haven't said anything about 90 degrees yet, right? Even though right angle means 90 degrees, we haven't made that jump in logic yet. So we have to say that. Measure of angle ABC equals 90 degrees. Got to put that out there. Now, how do we know that? Savannah? Definition of a right angle. Yeah. Okay, so, we know the measure of angle ABC is 90 degrees. I'm going to start the next step for you and see if you can finish it for me. Measure of angle ABC also equals what? Somebody who has not spoken yet. Look in the picture. You've already spoken. Okay, you haven't, right? There you go. Okay, so the measure of angle ABC is equal to the measure of angle 1 plus the measure of angle 2. Okay, and think back in your memory banks here. What tells us that you can add two angles that are adjacent and get the bigger one? There's a certain postulate. Yes? There you go, angle addition postulate. That's what we got to use here for this one. Okay. Now, can you take steps 2 and 3 and put them together? It's the step that you guys wanted to say earlier. How can I put those together and say something new, which is where we wanted to go? Somebody who's not spoken yet. Somebody who's not spoken yet. Yes, sir. Nope, not yet. Think simpler than that. Yeah. Right. Do you guys see how that works now? If the measure of angle ABC is 90, and the measure of angle ABC is 1 plus 2, then 90 equals measure of 1 plus measure of 2. We're putting those all together now. Okay. What did I just do there? Yeah? I turned measure of angle ABC into 90 degrees. So what did I actually do? Substitution. Right, that's a substitution. Technically, if you had said transitive property, I'd accept that too. Because you kind of sort of did that too, didn't you? You took two things that were equal to the same thing and made them equal to each other. That's the transitive property. So you could have said that too. All right. So we're up to the point where we've got measure of angle 1 plus measure of angle 2 is 90 degrees. It's like, good Lord, we've taken 4 steps just to get to that? Yep. Now what? What can I say next? Yeah?
Angle 2 is converted to angle 3. That means measurement of angle 1 plus measurement of angle 3.
Yep, you're wanting to jump ahead again. So your logic is sound, but you're wanting to jump ahead a little bit here.
Attention class representatives and King Queen candidates. Today during 5th hour will be the halftime rehearsal. Please check into your 5th hour and then walk over to the football field for practice. Thank you.
All right. I'm going to help here just a little bit. So, before we can start doing what Savannah just said, which I'm guessing most of you guys were probably thinking that was what's coming next, there's a technicality we have to deal with here. And students always hate this because it seems obvious, and why do I have to write that down? But technically, what I set up here as part of your givens was angle 2 is congruent to angle 3. Down here, I have an equation that I'm working with that involves the measures of angles, not the angles themselves being equal and that sort of thing. So I have to change the congruent statement into an equals. Okay? These are two technically different things, though one does lead to the other. So if I'm going to work in an equation, I have to change that congruent statement into an equals statement with measurements. Okay? And all you need to write for the justification for this is the definition of congruent. The definition of congruent angles says that if the angles are congruent, then their measurements are equal. So that's what I did. I took the fact that they were congruent and said, okay, now I know their measurements are equal. And if I have things that are equal to one another, then I am allowed to make substitutions with those things. I can replace one with the other in any equation that involves one of those two things. So if you look at the equation right above it, do you see where now I can make a substitution?
Yes.
Okay. Has to look exactly the same. Measure of angle 2 happens to be in that equation. Measure of angle 2 happens to be right here. So I can replace measure of angle 2 with measure of angle 3, right? Which is what I really want to do here. So step number 6, taking my equation from step 4, and it's measure of angle 1 plus measure of angle 3. And again, what did I just do? Substitution. Okay. And remember back to yesterday when we talked about those stupid different, what were they? Were they postulates? Yeah. The stupid postulates, the ones about or stupid properties, the ones that were the symmetric and reflexive that were dumb. Well, look up here. Look at where I'm at. Look at what I'm trying to prove. I have symmetric property technically?
Oh my god.
Then it's done. Then it's done. All right? I know. You will, if you leave off that step and you're doing like a proof, let's say you're on a test and this proof is worth 10 points and you did this much right here and you didn't do that, I would take off a half a point or something out of 10. So you'd have like a 95% on the proof. It's not worth a ton as far as the grand scheme, but technically if you want it to be a complete, totally correct proof, it has to be there. So I ran out, so I'm going to come over here and just finish up. So here's my step 7. So step 7 would be measure of angle 1 plus measure of angle 3 equals 90, symmetric property, and then I can do my QED to be done. Okay, but what I am most concerned with is not this stuff at the end. It's not the little technicality stuff. I mean, yeah, if you want a complete proof done 100% correctly all the way through, that stuff needs to be there, no doubt. But what I am most concerned about is all this good stuff in the middle here. Okay? Can I see in your proof that you were able to kind of logically go and connect the dots and go from the given information to what you were trying to prove? Can you show me a path that makes sense logically? Okay, that sort of thing. That's what's important about this stuff, is getting you guys to think logically and to see how one thing leads to another, leads to another, leads to another, and boom, I got it. That's deductive reasoning. That's what we're doing with these proofs. Okay? So I'm going to give you guys a little bit of a chance here to practice some. There's going to be a fill in the blank proof you're going to start with, and I'm actually going to do that one with you. And then you have 2 more in your journal you're going to do on your own. One is a fill in the blank, and one is all the way. And if those look good, then you guys can start your homework on this stuff. Okay?